Under the deep blue sea.
I have a bookmark, sort of a bookmark, in my notes so that I can find where we are.
Imagine that.
Good. Smart.
You're not. I don't know what to do. You're not.
I won this at the county fair for sewing a purse.
Hey, congratulations. It looks like a first prize ribbon.
It is. There were like 11 people who entered, so
First out of
It's not
11.
it's
Better
not
than first out of
such
2.
I mean, yeah.
You know, it'd be terrible if you got third out of 2. You did really bad then.
Yeah. I don't think that can happen, though.
I don't know. If someone hated your design that much, I think it's possible.
I don't think I have that purse anymore, actually. I don't know what happened to it. I think I might have given it to someone.
Getting a few people. I know Lauren won't be here today, and I know Kendall won't be on today. Not that I don't think Kendall's been here for weeks, anyways. But I know that those two won't be here because they're at Chick-fil-A. Oh, Susanna. She's so happy to be here. Ellie, did you get to watch any of those videos I posted yesterday?
The videos?
Yeah.
No, I haven't watched them yet.
All right. Make sure you do that because they're pretty good. They'll do a good job of preparing you for everything that you need, and also giving you an idea of the rubric. Because if you remember, the rubric originally they've changed it. It's now a 10-point rubric for the DBQ, and so keep that in mind. All right. Well, it's 11:04, so we can go ahead and start reviewing with the 8 who are here. All right. So we're talking about the scientific revolution today, and that means we get to talk about still get to talk about the church, and we're going to talk about how they loved change, especially when it came to science. And that's not it's a very facetious statement by me. So the first thing we need to know is science. How did the church look at science in general at that point? Like, what were some of the held scientific views?
The sun goes around the earth.
Yes, and what do we call that model?
Geocentric.
Yeah, it's the geocentric model. So it's the sun goes around the earth, and the earth is the center of everything. That's an interesting viewpoint to have. Also, natural philosophy, and basically that focused on the fundamental questions about the universe and everything. And let me see if there's anything else right there that needs to be happening. No, that looks good. All right. So who was the first person to challenge the geocentric method?
Tycho Brahe.
Okay.
Brahe.
Brahe is one of them, but yeah, he's the first one to challenge it. You're right. And who was his helper?
Kepler?
Who is singing?
That's my sister.
Oh, okay. All right. So, yeah, Tycho Brahe comes along, and what he essentially adds to the whole thing is he collects a ton of data. And it's actually Kepler who comes along and makes sense of all the data. And so he's like the fine working motor of the computer, if you will. And he's the one that brings everything down. It's like, oh, this is what all that data means. And whenever he was collecting data, he literally just went outside every night. I think it was for almost a year or two, and studied the sky and studied the stars, studied everything about space that they possibly could with the limited resources that they had at that point. And Kepler comes along, and he kind of changes and throws everything into a different mindset. First, he talks about a specific type of orbit. What does he come up with?
Elliptical.
Yeah, we have elliptical orbits. Instead of like these perfect circles, they're ellipses. And so everything travels in this. Also, he noticed that everything travels at different speeds around the sun. And so not only does everything revolve around the sun, but it travels at different speeds around the sun. Now, who was the next most important person in all of this study of the geocentric changing over to heliocentric?
Giordano Bruno.
All right, Bruno, yes, tell me about him.
He came up with that everything in space is constantly moving and spinning.
Mm-hmm. Yep. Always in motion, never stopping, never slowing. Yeah, that's very good. And then who invents the best way to be able to study the stars? Come on, the whole telescope.
Galileo.
Yeah, we're talking about Galileo. He's the one that comes up with that awesome invention. He also comes up with the law of accelerating bodies, which something to the effect of, I'm trying to remember, it's like 32 feet per second, I don't know, is how fast they travel. He also wrote a book called The Starry Messenger, if you remember that from your notes at all. And basically, it contradicts, and part of it, what it does is it contradicts this idea that the heavenly bodies are perfect. Do you remember did we talk about the Starry Messenger at all? Okay.
No.
I wanted to, because I have my notes here that I was supposed to cover, and I'm looking at them, and so I wanted to. So essentially, in this book, he talks about the imperfections of the moon, because with his telescope, he could see the moon a lot clearer, and so he mentioned that there were like craters on the moon and various other things. But the Catholics held this idea, and Copernicus is the one who kind of put it out there, that all of the heavenly bodies were perfect, and they were guided by angels, and they were led around, through space. The angels kind of pushed them around in space and everything. And so Galileo kind of goes out there and he's like, actually, they're not perfect. They're imperfect. There are craters and there's all these different problems. And so Galileo, if you remember correctly, got into a little bit of trouble for his views, so much so that he was put under house arrest and eventually put on trial by the Inquisition. Everyone loves the Inquisition.
No one expects the Spanish Inquisition.
Absolutely. And there's actually a legend that I came across recently in just looking at this whole situation. It said that even though he recanted, he said underneath his breath, now this is legend, we don't know if it's true or not, but that he said under his breath, the earth still moves, was the last thing he had to say about the whole process. But Galileo got to keep his life, but he was kind of under a microscope for the rest of his life. And so the church, you can kind of see, wasn't too keen on changing things. I don't know how many of you know this, and I did mention it in class. It wasn't until 1992 that the church actually agreed with the heliocentric model. Like, they said that they were wrong and that the heliocentric model is correct. So that means that the church, the Catholic Church, held on to this view for almost 300 years after it was just, discovered that, hey, it's not a geocentric universe, it's a heliocentric universe. So that's the church holding on to their ways. Isaac Newton is another person that we need to talk about in the scientific revolution. What did he do? What's he important for?
The laws of.
I'm coming.
So,
The law of gravity?
yeah.
I thought that's what you were saying. Then I heard I'm coming, and it kind of overshadowed you. So yeah, the law of universal gravitation, and also centripetal force. He worked with that. Remember, Newton was big in the field of physics, and so he was very important in that area. He wrote a book. I'm almost 100% sure we talked about this book.
Are you talking about Principia?
Yes, Principia Mathematics.
3 times.
Huh?
I mentioned that 3 times.
Okay. Principia Mathematics, yes, he did write that. And he took the astronomy of Copernicus and also added Kepler's laws to it, and, was able to make great leaps and bounds in the field. And he also came up with the 3 laws of motion and mechanics in that book, the Principia Mathematica. And I'm trying to think if there's anything else for him. Oh, yeah, the law of universal gravitation in general, just that everybody in the universe attracts every other body in a mathematical way. So in other words, the gravity of each planet, the gravity of everything out there, attracts things differently and causes it to do different things. For example, the distance that the moon is from us determines its orbit, how fast it spins in its orbit, how often it goes around the Earth, so on and so forth. So all of that has play in universal gravitation. Let's see. I'm going to make sure we get all these scientists, and there's a ton of them. So if I'm going too fast, please let me know, and I'll slow down. But Francis Bacon, did we talk about him?
Yep.
Yeah, he came up with the scientific method.
Yeah. All right. And what is the scientific method?
Experiment, or observe, experiment, something.
Yeah,
I don't know.
It's basically where you come up with a hypothesis, you experiment, you do everything, and then if it all works out, you have a theory. If it doesn't work out, back to the drawing board. So the scientific method was very important for science in general because it gives a constant for them to work from. And it's not just like a bunch of guesses and everything else. Descartes, we talked about him, right? Really be Descartes, but Rene Descartes. He also was important for the scientific method as well. I don't know if we did talk about him, but him and Francis Bacon kind of go hand in hand in that story. And so they, I guess Bacon would be more known for his use of inductive reasoning, and Descartes would be known for his deductive reasoning. Do you guys know the difference between those two?
Slightly.
Like, what is inductive and what is deductive?
Isn't deductive making a theory off of facts, and inductive is having all the facts and something like that?
Well, yeah, it's deductive is where you have facts and you work forward from there. Inductive is where you take like a guess and you work forward from that. Essentially, you always want to use deductive reasoning. Inductive leads you down some wild paths if you're not careful with that. So deductive is much better. And yeah, I think that's all you need to know about those two. Just the fact that one was inductive, Bacon, and the other is deductive, which is Descartes. All right, that leads us to medicine and the changes that were made in medicine. Remember, just like the church held Copernicus's theories of geocentrism as the gospel truth, as in nothing could change that, that the same was true for a scientist named Galen. And Galen came up with this idea that the body is made up of 4 of these. What are those?
Humors.
Yeah, not funny stuff. Essentially, you've got 4 humors, and anytime one is out of balance, what happens to you?
You get sick.
Yeah, so the preferred method of healing people was to do what?
Bleed them.
What do they do to you to make you better?
Bleed them.
Yes, they would bleed them. They would cut you open and say, all right, once we get everything back in balance, you basically have too much blood and we need to fix that. Not a good idea. We've come a long way in our understanding of the body and science in general to know that, not a smart idea. And so, but you have to understand Galen's theories of the body were as widely accepted by the church as Copernicus's were. So both were super wrong, but it's something that if you went against the church in this, it was very, very bad. So it's not something you wanted to do. Now, did we talk about Paracelsus? I feel like we did.
Yeah, he was considered the father of toxicology.
Mm-hmm.
So
And essentially, when we say toxicology, what are we talking about? How do we talk about that today, or mention it today?
like substances that make you sick, poisons and such.
Yes, but in that case, he was a master at using them to heal you, though. So you could use a lot of these things, these what we call poisons. They're only poisonous in large doses, but if you take them in small doses, they can actually be somewhat helpful for certain diseases and everything. And he kind of mastered the use of those. So really, he's more of like your first pharmacist, if you will. He's able to master that use of these different things, rather than the use of bloodletting. I'm sure some people probably thought he was a wizard doing all of this. How about Andreas Vesalius? Pretty sure we talked about him because he's kind of a big deal when it comes to the body.
Yep.
Yeah. Father of biology.
There you go. What did he do? He did something that was very bad, at least according to the church.
Dissected dead bodies a lot.
Yeah, he would get dead bodies and he would dissect them, and this was looked down upon quite heavily by the church, and it's the view of the body and the sacredness of the body and all of that. And so it was not he was very risky with his everything. And so Vesalius was important in helping us to understand the body and understand everything about it. How about William Harvey?
Yep. He studied the heart and circulation of the blood.
Yes, he studied the heart and he discovered the circulation of the blood throughout the body. And he also understood that the heart worked like a pump, and it pumped that blood throughout the entire body. Robert Boyle.
Yep. First modern chemist.
Yeah, he's your first modern chemist. He discovered Boyle's law, which states what?
Something about fluid pressure.
Yeah, the pressure of gas varies inversely with volume. So the pressure of gas is basically going to change based on how much volume of gas that there is. And so it's Boyle's law that he worked on and he was able to come up with. Now remember, which person was responsible? Because I remember I showed you some pictures of like the human body that were very detailed at that time, and then you could see like the veins and everything, and you could see like muscles. Who was responsible for that stuff? I remember Susanna was quite enamored with all of this.
Vesalius did some drawings.
Yes, Vesalius was the one. Yeah, Vesalius was able to come up with some very perfect drawings, if you will, very specific drawings. And so, Vesalius was the artist for all of that. Did I skip over anyone? Did we miss anybody?
I think Franciscus Silvius.
Oh, okay. Tell me about him.
He did a lot of work with chemical biology.
Yep.
Like what kind of substances plants can make and stuff.
Yeah, it was a lot of work that would gear towards the same study of like pharmacology, so pharmacies and all of that kind of stuff, being able to use plants to heal people and to be able to help them out. So yeah, he's another person that was instrumental in lots of those types of things. Basically the founders of CVS and Walgreens, if you will. All right. Anything else? I can't stress enough. I posted a lot of videos yesterday, and yes, it'll probably take you about an hour to watch all of them, but I can't stress enough, like those videos are going to help you out tremendously. Like I said in the post yesterday, I watched them all and I was going to basically recreate it. And then I thought, well, that's dumb. There's no point in me recreating them, but I'm basically going to create an assignment where you're going to have to, the Heimler videos, you're going to have to recreate, give me like a few notes from that. And it's going to be an assignment that I post later. So if you've watched it, make sure you kind of like write down a few things that he notes. And it'll be both of them. It'll be the rubric for this year's DBQ. Remember, it's a 10-point rubric instead of, I think it's 7 before. And also the one where he kind of breaks down the DBQ question and shows you like thought processes that you can use. So just a few notes. It doesn't have to be everything. And I don't want you to think I want you to watch it and copy like everything down. Just show me that you at least paid attention and watched the video. Because like I said, it'll be very helpful for you. Also, for those of you who joined in after we'd already started, there is, if you go to YouTube and you search advanced placement, there's a bunch of review videos for AP Euro for units 1 through 7. They're not that long. Usually the videos themselves say like 45 minutes, but the review itself is only about 15 to 20 at the most. And then there's also, they cover units 8 and 9. I don't think I'll be able to cover unit 9 just because I'm trying to get these reviews done. So unit 9 is something that you probably want to at least have a grasp on, because that's the Cold War before next year's history classes, to be able to know the Cold War from both sides, because next year you'll learn it from the American side. So the European side would be important to note as well. All right. Any questions? No? No. That's unit 4. So we'll cover unit 5 next time. Next Monday, we'll do it. Yeah. If you're good, you're free to go. If you don't have anything for me. Elior is just like, I'm just gonna sit there, just hang out.
I don't really have anything else to do. Also, my phone died in the middle, so if I left and then came back, I had to join on my computer.
It's not a big deal. Don't worry about that.